My name's Caruso. I'm from the University of Colorado Boulder in Dr. Sunita Mello's lab. The one non-eye tracking talk in this session, but continuing the thread of mind wandering in this talk. So I'll be talking about the associations between mind wandering and learning from complex texts and how this varies by assessment depth and time. So we're all readers and we all extract information from text every day. If you're a student, you might be reading a textbook and you might be reading it so that you can apply that information to a test, maybe several weeks down the line. But even if you're not a student, you might be reading a text in hopes to apply that knowledge to your job. But in general, the world is very information driven. So this ability to learn from complex text is a very key critical skill. So whether you're understanding this text that you're reading depends on several factors, but one of these factors is your ability to pay attention to the text. And these lapses in attention while reading, called mind wandering, zoning out, in Caitlin's talk, it was task-unrelated thought. It's no surprise that if you are mind wandering, you're not paying attention to the text, you won't understand it as well. And that's why it's no surprise that mind wandering has been shown to be negatively correlated with comprehension outcomes. If you don't pay attention to the text, you don't understand it as well. But reading comprehension itself involves several interacting levels of processing. On this shallow level, you're looking at a word, encoding it, identifying it, accessing that word level meaning, and you're using that to construct sentence level meaning. Beyond that surface level meaning, deeper processing is building a situational model of what you read. And this is done through bridging inferences that connect ideas. And while we're connecting ideas across sentences, we're also connecting ideas across the text as a whole through elaboration. And all the time, prior knowledge, prior knowledge is affecting what we understand as well. So you can see how these different factors are each influencing each other, and they're creating a very complex process that's helping us understand these texts that we read. So when a person mind wanders, you're directing your attention inwards towards personal thoughts instead of outwards towards the text. And this can create encoding failures. So as a fun example, to illustrate this, I have a short story about Goldilocks. It says, Goldilocks entered the bear's house while they were away. She ate their porridge and fell asleep. Later, Goldilocks breathed a sigh of relief. So from this, you already have an image of your mind of the situation of Goldilocks's story, but a lot went on mentally to put that all together in your mind. So like I said, on the surface level, you probably looked at the letter G and identified it as the letter G. And from there, you put together the word Goldilocks, and then you even parsed the sentence as a whole as you went word by word. So from here, you create a literal factual representation of the text, which was that text-based. For instance, you now know that Goldilocks ate the porridge after entering the bear's house, and she fell asleep after eating the porridge. And then finally, readers construct a mental model that is called that situational model, and that integrates information not only on this page, but on previous pages of the Goldilocks story that you also read. And this whole time, prior knowledge is also helping you understand. Most people know that bears are scary and you wouldn't want to face one in real life. So that's why in the end, you might be able to guess that she breathed a sigh of relief because she did not come in contact with any of the bears. So when the situational model comes together, you have this deep mental image. And overall, this illustrates that kind of complex interplay between everything in the process that's going on. So imagine if you had been mind wandering on the second sentence though. So for instance, you missed the fact that she ate porridge, that she fell asleep. So if I ask you, why did Goldilocks breathe a sigh of relief, you might be confused, or You might be able to use some prior knowledge and heuristic processing to know that bears are dangerous. She did not come in contact with them, so she's still overall relieved that she did not meet the bear. So if I asked you a question about that, you'd still be able to answer it. But if I asked you a specific factual question, such as, what did she eat? You wouldn't be able to answer porridge. So overall, this illustrates the complex interplay between all these factors and mind wandering and comprehension. But comprehension, while it unfolds at different depths, it also unfolds at different times. So over several milliseconds, you're looking at that word, you're encoding it, or in several hundred milliseconds, yeah. And then storing that into working memory. And from there, you can use it for a time, and you can also consolidate it into long-term memory. And during this whole process, prior knowledge is affecting how information is encoded and remembered. So illustrating this again with the Goldilocks example, it's a little harder because the short duration of this presentation, you probably still remember the story, but you probably don't remember it word for word. And will you remember it as well when you leave this presentation or when you're flying home from the conference? It might depend if you're mind wandering while listening to my slides right now. So we've all caught ourselves convinced we're going to read a page of text, remember it so we can apply it later, only to find we read the whole page of text and didn't pay attention at all. And that might affect, you won't even remember that page of text 10 minutes later, let alone in a couple weeks when you have the test. So the motivation for our study is to look at and examine both this comprehension depth and this comprehension time, and examine its interplay with mind wandering. So our goal, there is, however, gaps in the research regarding this, and our goal is to assess these gaps to better understand that interplay, mind wandering, comprehension, depth, and time. So previous meta-analysis by Wang et al. Was published in 2022, and it showed over many reading studies, mind wandering correlates on average negatively with task-unrelated thought, or mind wandering correlates negatively with comprehension. But most of these reading studies investigated mind wandering, only asked very factual rote questions, and only immediately after reading the text, never at a longer delay of days or weeks later. And additionally, yeah, so this very small number of studies looking at comprehension that did not include longer time periods or deeper depths is surprising, considering the reason we all read is to remember it and apply it later. So whether you're that student or the person reading for their job, you want to be able to remember it and apply it later. So rarely do people only want to read something and apply that knowledge immediately after, unless you're a student maybe cramming for a test in 10 minutes. So that's why we wanted to more deeply investigate these nuances between mind wandering comprehension depth and comprehension time, and include questions that aren't just rote comprehension asked immediately after, but deeper comprehension asked even up to a week later, to help fill in these gaps in the research. So how we did this, we used a large data set of about 177 participants, and they read long connected texts. This data was collected as part of a larger study. Participants read 5 texts, each 10 pages in length, and it was all about the general concept of scientific methods. And then we probed them for mind wandering twice per text. And these mind wandering probes were essentially a question after you read a page. It said, were you mind wandering on the previous page? And students answered yes or no. And we also instructed them to make sure they knew what mind wandering was so they could answer the probes as accurate as possible. So comprehension assessments consisted of rote, inference, and integration questions. These questions were asked at 4 different time points, first immediately after reading a page, then immediately after reading all 10 pages of a text, then immediately after reading all 5 texts, and finally, we sent them assessment via email a whole week later after reading the text we gave them. We then used a multi-level regression model to assess the comprehension depth and comprehension time as moderators. So back to the Goldilocks example real quick to illustrate what these questions got at. Rote questions targeted factual knowledge on a page, kind of like I mentioned earlier, I might ask, what did Goldilocks eat? You'd be able to answer porridge if you weren't mind wandering on that sentence, hopefully. Inference questions targeted knowledge implicitly stated in the text. We gave an inference and students answered true or false. So I might ask here, why did Goldilocks breathe a sigh of relief? Or did Goldilocks breathe a sigh of relief because she was happy she didn't come into contact with the bears? You would say true. And lastly, integration questions targeted integrative knowledge across multiple pages of text. So here, imagine you were reading several fairy tales. Then we might ask, what's a common theme that you see appear across these fairy tales? So what did we find? Oh, that's for integration. So what did we find? We looked at this three-way interaction between mind wandering, comprehension depth, and comprehension time. There was a significant two-way interaction between mind wandering and that comprehension depth. Mind wandering was a significant negative predictor of rote and integration comprehension, but not that inference comprehension questions. And additionally, the slopes for both rote and integration were similar. They were on par. So mind wandering does not, or in our study, did not correlate more negatively with one comprehension type over the other. Yet it did not correlate with that inference comprehension. And this was an interesting finding. It could be that individuals relied on their mental model construction and prior knowledge to be able to fill in the gaps when they were mind wandering on those inference questions, similar to how I described before with the Goldilocks example. But more work is needed to explore the relationship, especially with these deeper levels of comprehension, like the integration questions. There's also a significant two-way interaction between mind wandering and comprehension time. Mind wandering was a significant negative predictor for the during reading, after each text, after all text time points, but not for that delayed time point where we gave those assessments a whole week later. And this was very interesting. It might suggest that mind wandering is associated with deficiencies in initial encoding and mental model construction, but not with subsequent processes. But to our knowledge, this is one of the first studies to look at mind wandering at such a delayed time point. So this does highlight the need for more research that includes these time points in mind wandering and comprehension research. Also note that our model did not show any significant three-way interactions or any two-way interactions between comprehension depth and comprehension time. So this research is a push towards filling in those gaps that the Wong et al. Meta-analysis brought to light, but it's only a very small step because we need to replicate this data and we need to include these time points and these depths in more research. We found that the relationship between mind wandering and comprehension is complex, and some of these findings are non-intuitive, but it's important for developing and improving computational models of mind wandering. For instance, those that aid in the detection and intervention of mind wandering. The more data we have with more depths and more delayed time points, the better we can help students. We can intervene and help students and make sure that the comprehension we're helping with will stick over long periods of time. So with more research, we can better understand this interplay between mind wandering and comprehension depth and time, so we don't fail to account for these long-term comprehension. So while the study is a step in the right direction, more research is still needed to address these critical gaps. Thank you. Thank you to Cindy DeMello and my colleagues at University of Colorado Boulder, and I'm open for questions.